Welcome back to our Tech Deep Dive, episode 61. Today, we're venturing into what I call the API forest. You know how it goes. You start with a clean plan to split your big, clunky service into smaller, manageable pieces. But instead of a neat garden, you end up with a tangled, chaotic jungle of APIs. So why does decomposition, which is supposed to simplify things, often create an even bigger mess? Let's figure it out. The core of this problem lies in a few key concepts. First, we have hooks, which are the points where different services connect and talk to each other. Then there are service boundaries, the lines you draw to decide what each service is responsible for. When these boundaries aren't crystal clear, you get what's called an interface explosion. Suddenly, you have way more connection points than you ever anticipated, and managing them becomes a nightmare. It's like every little piece of your system needs its own special way to talk to every other piece. To make this easier to grasp, let's use a logistics analogy. Imagine your original monolithic application is one giant central warehouse. All your goods, your data, and functions are stored under one roof. It might be a bit disorganized and slow to find things, but at least everything is in one place. You know exactly where to go to get what you need. A single entry and exit point handles all incoming and outgoing trucks. Life is simple, if a bit inefficient. Now you decide to break this down into microservices. This is like replacing that single huge warehouse with a network of smaller, specialized warehouses. You've got one for cold storage, one for fragile items, one for bulk goods, and so on. Each warehouse is highly efficient at its specific job. This sounds great in theory, right? Specialized teams can manage their own warehouses, optimize their own processes, and work independently. You've decentralized the operation. But here's where the forest starts to grow. What are the interfaces in this analogy? They are the handover points between these warehouses. If a customer places an order that includes a frozen pizza, a glass vase, and a bag of cement, you can't just send one truck to one location anymore. The request has to go to the cold storage warehouse for the pizza, then to the fragile items warehouse for the vase, and finally to the bulk goods warehouse for the cement. Each transfer between warehouses is an interface. A truck leaves warehouse A and arrives at warehouse B. That's one interface. Then it goes from B to C, that's another. The problem is that the number of these handover points doesn't just add up. It can grow quadratically. If you have 2 warehouses, you might have 1 or 2 routes between them. If you have 10 warehouses, the number of potential routes and connection points explodes. You now need a complex logistics network just to move goods between your own facilities. This network of roads and loading docks is your API forest. So the core insight here is that when you move from a monolith to microservices, you're not eliminating complexity. You're shifting it. The complexity is no longer about the sheer number of functions inside one giant black box. Instead, the complexity now lives in the number of interfaces and the intricate relationships between them. What used to be a simple, internal function call inside your single application is now a cross-boundary network request. This request has to travel over the network, deal with potential latency, handle authentication, and be prepared for the other service to be temporarily unavailable. Each of these new network calls introduces a point of failure. Before, if one part of your code needed data from another, it was a direct memory access, incredibly fast and reliable. Now it's a journey across a digital highway that could have traffic jams, roadblocks, or even be closed entirely. The internal logic of each service might be simpler, but the system as a whole has become a complex, distributed web of dependencies. Managing this web is a completely different kind of challenge. You need new tools for monitoring, tracing, and discovery just to see what's happening. And this leads us to the real ticking time bomb, versioning. With a monolith, when you update a function, you redeploy the whole application. Everything is updated at once. It's a big event, but it's coordinated. In our API forest, each service can be updated independently. What happens when the team managing the fragile items warehouse decides to change their loading dock protocol? Suddenly, the trucks from the cold storage warehouse might not be able to connect anymore. Their delivery fails. This is the versioning nightmare. With so many interfaces, a single change in one service can have a ripple effect, breaking other services that depend on it. Let's say Service A version 2.0 is released. It now expects requests in a new format. But Service B, C, and D are all still sending requests in the old format of version 1.0. Do you force everyone to upgrade at the same time? That defeats the purpose of having independent services. Do you maintain both version 1.0 and 2.0 of your API? Now you have twice the maintenance work. This problem gets worse with every new service and every new interface you add. One small upgrade can trigger a cascade of failures across the entire system. You become trapped in a web of backward compatibility issues and forced upgrade cycles. You thought you were gaining agility, but now you spend all your time coordinating updates and fixing broken integrations. This is the hidden cost of the API forest, a challenge that many teams only discover after they are already lost deep in the woods. So is splitting services a bad idea? Not necessarily, but it requires a fundamentally different way of thinking. You can't just focus on the logic inside each service. You have to obsess over the design of the interfaces between them. The boundaries must be stable, well-documented, and thoughtfully designed to minimize dependencies. You need a clear strategy for versioning and communication from day one. Without that discipline, your beautifully planned microservice architecture will inevitably decay into a tangled, unmanageable API forest. Thinking about how to navigate this forest? We'll dive into strategies for taming this complexity, like API gateways and contract testing, in our upcoming videos. Make sure you're subscribed so you don't miss it. Thanks for watching.